There we go.
Thank you very much for the invitation. I need to close this. Oh, actually, I can see it there. So I'm going to say a few words about how we use Jupyter in Paris-Saclay and what are some of the features that we like. And then conclude with a project that we have for deploying Jupyter at large scale in France for education. So first, what Jupyter is, if I can, yeah. And the flagship of, so Jupyter is a big ecosystem, and the flagship is the Jupyter Notebook, which most of you already know. And it's all about being able to write documents that mix a bunch of different things, or that can mix a combination of things, which is narration, telling a story, computations, visualizations, interaction, and programming, or any combination thereof. And actually, this may not look like a Jupyter Notebook, but actually what you are seeing right now is a Jupyter Notebook. There it is, as a Jupyter Notebook. And let's come back to slides.
You're missing deduction.
Not yet. I agree. Exactly. Isn't that almost extra code? So that's where you should be working. And so far, I've started to tell a story. So we have done some narration. So let's do.
So there are no kernels for any purposes.
I mean, there's the MMT kernel, right?
Yeah, but
Right. There is a kernel for code, but it's not a proof assistant. I don't know. That's something that would need to be checked. I wouldn't be surprised.
Proof assistant.
Oh, I mean, came on.
Okay.
And there might be a kernel for code. I don't remember. But yeah, that's definitely something to check. And it would be nice in demo to have the working. So, for example, here, a little mathematical computation, which I'm going to do. And if at any point someone in the audience would want me to change the computation, I can actually change the computation. And I didn't try. I don't know if it's going to integrate well. Maybe it's not going to integrate well. I will leave it some time to. Okay, that was not a good idea. Try. What is it doing?
but the integration is easy, right? So
Apparently not if
is
you
it like a network problem?
Oh no, it's just that's
Oh,
okay.
it's not easy, that's why.
So that's okay. So
Easy for Florian.
yeah, which is also maybe occasion to start a discussion later, which is right now I believe it's using math. Yeah, it's using MathJax.
What brought the formula is and how wide it is.
Can you scroll to the right? I just want to see how far it goes.
It's yeah, okay. Okay, MathJax may have having
Yeah, I think
maybe
you
having
need
some problem.
to hit a couple of propellers minus
Yeah.
to show the formula. Make it smaller.
Yeah. Yeah, I think we're pushing MathJax the border. Okay, that was not planned. But it's interesting. It's interesting if I can get back. Okay, can I come back and okay, I will restart the book.
I think you just need to skip
That
it because
one-
it's
that-
slowed down, I think.
That's via MathJax.
Yeah. Hello, restart.
Well, let's see if Chrome will do better.
Okay. Yeah, I think I will just reload the page.
Just wait a-
Just reload the page.
Michael, you're not seeing this.
Oh, I'm sorry. Yeah, I'm sharing. Okay. I thought I could use the to send the email.
Just use Kotek instead. That might fix it.
Say this again.
Switch to Kotek.
Yeah, I would love to.
I think you need to kill the process, like using
Yeah.
the emergency mode, Control Del.
Well, Control Del
Ah,
actually.
something just happened.
Yeah.
Okay.
It's still a MathJax thing.
Okay, let's just kill the window and reopen the window.
It's using LaTeX again?
You know, the previous tab, right?
Ah, okay.
No, no,
Is
I
it
was
still
just
like
confused.
the computer, or no? Okay, no.
I just use it for thing.
Let's see.
So obviously we need a project about Jupyter.
Yeah. About how to do nice mathematics in the browser.
While teaching.
Exactly.
Exactly what you're seeing is instead of the art already.
All right. So this is about doing, let's say, visualization, moving around math, and we can do more. This is a little demo of making a small interactive application. So here you have some data about, so each round here is a country. On one axis, it's going to be the wealth and the life expectancy over time, and you can move around and see how things evolve, and you can interact with the data and ask things about the interactive visual. Having little applications allow you to do interactive visualization. All right. My laptop is slow. What is it doing now? Okay, so what's new? Did I show everything? Yes, it's distracting. So what's new already there? Notebooks is not a new thing. Back in the 90s, I was already using notebooks in Maple. Actually, I don't quite necessarily like it. It evolved with time. And I'm sure there were notebooks earlier than this, and then Sage has its notebook in the late 2000s, and then IPython and so on. So what's new here with Jupyter is that it's web-based. So that came first with Sage ND, so which means that it integrates well with all the things that allow us to do things either remotely on your own machine. It's using modern technology. Of course, there's always something hard to define what's going to be modern later. But, and it's very interoperable. In particular, it's not been meant like the others for a specific system or language, but it can be used with many, something like hundreds of, I think by now we are close to 100 different languages, including, of course, Python, Julia, R, C++, and a bunch of others. And it's widely adopted. If you look around on the web, you find millions of notebooks and its use of teaching, for research, engineering, and etc. And another thing that is important is the notebook is just one piece of the whole stack. Altogether, Jupyter, it's an ecosystem of free software, of standards, of web services for interactive computing. It's part of the platform. So why would you care about using it for teaching? There's a nice reference by a group of teachers led by Lorena Barba, which is teaching and learning with Jupyter. Here are some examples. So this is a little extract of a course of mine about graph theory and computational graph theory, and there is a bit of narration here with some math definition, and then let me check something. There is something slow on my laptop, and I will check it. Just Zoom. Is it just Zoom that is being? Yeah, I just Zoom that. Yeah, it's hogging me. Okay, I will do it. Yeah, it's in French, but you don't need to understand the French. That's fine. And then in this class, one of the purpose of this specific lecture is to learn about graph search algorithm and the algorithm there, which I should find. And then there is this little gadget. So I want my student to understand it, and to understand graph search, usually just do a lot of pictures on the web, on the board. So this is a little mini application that can be seen. Essentially, it's a visual debugger specialized for graphs. And so now if I run my computation, I do get a visualization of the graph, and I see the algorithm in action, and I can control and move around in time to see what the graph is actually doing. And this works for this particular algorithm, but later on, if they do their own algorithm, they can reuse the same applications. So they can use it to debug their own implementation. So we have, when we say that we could combine, so we could combine narration, programming, visualization, interaction, and computation, and adding all of them together is what's interesting. This is another example where it's about learning by example. You show something and then you let people repeat. So we have an introduction to data science class. Right in the beginning, they've already done Python, but it was last semester. So we remind, oh, here is an example of function. Okay, now write your own function, and so we have to write it. Okay, and maybe we're going to do something like L because we don't remember how you compute. And then the next cell is going to give them immediate feedback. Oh no, that was the wrong answer. Oh yeah, right. I should think more. I try again, and I get the right answer. So the student can just follow the narration, and then they get feedback if, okay, probably they know what they are doing, or maybe it would be a good time to stop and think. And because you can do little interactive application, you can implement those kind of little serious game. So here you have a maze, you have an ant that you want to get out to the door, and you have to write the little program. The students have to write the program to get it out. And here is nothing specific in Jupyter, but Jupyter is an environment where it's easy to define those little games. So in Paris-Saclay, we use it as a stage for dozens of computational and programming courses in the math, biology, physics department, so in a bunch of departments. And in particular, we use it quite some for large courses with hundreds of students. And the motivation for this is that we have found that it does bring autonomy to the student because there is a linear structure. You tell a story and they're following the narration and their activity to do, but all in a linear document. They have a clear path to follow. They know where they should be taking action. So it's for example, for introduction to programming class, before we were using C++ and they had a window with the compiler, a window with the terminal to run the compiler, a window with the subject telling them what they had to do, and having to move from one to the other. Each time they would switch from one window to the other, would forget, oh, what am I supposed to do now? And they would stop. So they were not in this flow that just brings them and keep them active. And also it gives them, because it's interactive programming, it gives them very quick feedback. Oh, that's wrong, let's try again. And just quick loop, which encourages them to try and try and try again until, and less risk to get lost on the way. And so this encourage students to proceed each at their own pace, or good student can go very fast and go to more advanced sheet that we provide for them. And more fragile student will go slower, but can then the instructors can focus on helping the fragile students or with a student which at a given point. So that's really what we have noticed, is that instead of interacting with 20 or 30 students during the lecture, most of the time, most of the students would just go smoothly or just add one question, and then we could really take time. Okay, today I'm going to sit with this guy who is having trouble and need me. And also it does support hybrid teaching, so that students that have been away for some reason, they have all the material and then they can work on their own and know where to go more easily. So it's gives some support to full range from fully tutored classes to something where it's more working for them. It also gives some flexibility. So because we have a Jupyter deployment, students can work either in computer lab on their own machine, they can work online on the laptop, on their cell phone, whatever, and they are always exactly in the same environment, so that when they say, oh, this is not working, I don't have to ask them all the details. Oh, which version of Python do you have, and so on. So it makes it easier. And the nice feature of Jupyter is that it breaks down the usual separation that you have between, on one hand, users and developers. And here, since in the same environment, you can be reading or using documents, or you can be offering documents, or you can go actually to something more advanced and starting developing, doing your own application. So you have this whole spectrum that you can do in the same environment. And this is really nice, because this means when you have a community, the power users can progressively make progress, explore, try new things, and whenever they discover something, they can share it with the others, and progressively you can have the community move forward. Whereas if you're in a world where you have developers on one hand and users on the other end, well, it will always stay the same. Users will always be users and won't make progress. Some caveats and tips. So one of the nice features is this linear flow, and students get trapped in this flow and they start working and then they keep on working. And usually at the end of the lecture, I have to tell, oh, stop, it's time, you're finished, and they want to keep up. So that's a nice feature. At the same time, we tend to go in this same mode as when we are using almost social network where you scroll, and you just get lost there and forget to think. So you have to be active about this. One of the actions that you can take is have short notebooks that are focused on one task, so that once the task is done, you can ask them to stop and think, oh, what did you do? What did you learn? And also, it's less prone to be lost in this big notebook. Try to make the actions as diverse as possible. So sometimes we should be more in a reading mode, and sometimes it would be more trial and experiment. Sometimes we should be writing code, debugging code, taking notes, and try to switch from one to the other. So that, and in particular, have points where you say clearly, there is something you didn't get. You should stop and think now. So having a red flag, a big red flag, is important. And then providing interactive and visual feedback, even just an oral message is already something that helps. Also, people often complain, and rightfully, that notebooks get messy. But the point here is that a notebook is something that is very flexible. It's like a piece of paper. And if you put a 5-year-old in front of a piece of paper, it will just scribble in any way. We have been trained to organize how we write on a piece of paper, depending on the kind of task that we have in our hand. And for the same reason, because Jupyter notebooks are very flexible, you do need to get trained to actually use it properly. If you just try, and it will go nowhere. So what you can do to help your students is first provide pre-structured notebooks, and you can actually turn some pieces to be read-only so that they can break things too much. So already have a structure for your student. Don't forget to actually train your student to tell them what the best practices are. Be careful about what you use the notebook for. In particular, be careful about separation between what is telling a story and what is writing code. Notebook is not an IDE. So if the code is not relevant to the narration, it should be in a separate file and you just import it, for example. And also, notebooks are good when you want to combine together narration or views. If your task at hand is specialized where you only do one, for example, if you just do programming, of course, you should be using an IDE. If you just do narration, you should be using a normal word processor and so on. It's not meant to replace everything.
One question.
Yes.
How true is that? How true is that really? I mean, Jupyter Lab does have some IDE functionality, right? Like at least it does something like
Yes.
syntax highlighting. Does
Right.
it also do auto completion when I press button?
It does.
Yeah, okay. So in that sense, it basically is an IDE.
And
right?
so, which is why I'm speaking out. Don't use a notebook.
Yeah. Okay.
I'm not using.
That's
Don't use Jupyter.
Yeah. Okay. That's
And even depending on the kind of program, if you want to do advanced programming, I would suggest using a real IDE. Jupyter is an IDE. Jupyter Lab is an IDE, but it might not be the best IDE on earth. And
that's probably fair, but like conversely, I've noticed that like at least VS Code, but I think also IntelliJ do have Jupyter notebooks functionality, and it gives you exactly the same functionality in the code blocks that it does in the normal IDE. So yeah, okay.
Well, that is okay. Maybe I should phrase it the other way. If you use Jupyter Lab as an IDE and don't find it that it's the best IDE, don't complain.
Yeah,
it's not meant to be the best IDE on.
But probably whatever IDE you want to use probably also has support for Jupyter notebooks. So.
Yeah, if it's good enough for you.
Yeah,
sure.
So what if you want to do? You want to introduce a new concept narratively, which might involve some definitions and formulas and stuff, and then implement an algorithm associated with it, how would you do that?
Well, typically I would tell them to use some ID to actually, so I have the narrative as a notebook and then let them switch to an ID to actually do the development.
No, but also the narrative, like how do you write the math in the
narrative?
Yeah.
You can put $i. It's marked down, so you have all the features that you have for all the, as good as it is.
Use math jacks.
And well, you write $, and you write your math between $.
Yes.
And then it turns out that the current implementation is using math jacks, but there is no reason why you couldn't be using something else.
Yeah.
Maybe that's actually something that would be an interesting thing, is that in pushing for the use of MathML or whatever in.
Well, the only reasonable way of writing MathML is via later. Anyway.
Yeah, but yeah, so this is a question of rendering.
Yeah.
You can probably also do it in fact using LaTeX syntax using math check somehow, right?
That's what MathJack does.
Yeah.
So if you're currently,
but you just showed it in the output of your so I'm guessing the Python code does some math checks thing.
Yeah. So well, it's actually it's not even the Python code. It's the Jupyter.
The Jupyter library.
The Jupyter front end decides to render whatever is between the $s by calling math checks.
Yeah,
but
you
that's
could probably also write like LaTeX syntax in your markdown stuff, and then math checks would pick up.
It's
yeah. Okay.
So the courses you're using Jupyter for, are they courses to learn programming or courses to learn math?
Programming, and so in my case, it's programming or computations or computational maths. I haven't had a need. Well, these days I'm not teaching pure maths. Presumably, if you would be teaching something that would not have a computational aspect in some way, at least as a way for the students to exercise themselves, then probably Jupyter is not the right tool for it. It's interesting once you want to mix computation and narration.
So let's say I want to define derivatives.
Mm-hmm.
And I have a big chunk of math to define that. And I have all the theorems how to derive polynomials and stuff. Then I would immediately implement the algorithm that gets an elementary function and computes the derivative. And how would you use the notebook for that?
Presumably use so
is that something you would do ad hoc, or is there some kind of pattern that you apply to?
So the question is, first, what is a computational system that would be relevant? Well, it depends if you do you care in this case more about the computational side or about the proof side of it?
I don't know. I might have a Python data type for elementary functions or something, and then a function that takes one of those functions and returns the derivative.
I would really say, first thing, what are the computations that you want to do and what system you want to do for this, which is the first one step, and then how do you want to integrate this computation into your narration? But somehow it's almost as soon as your whatever computational system you are using can be used from Jupyter, it's decoupled from, it's distinct from Jupyter.
So the two extremes are use the Sage kernel and use the Python kernel and basically implement it from scratch, right? And anything in between.
But here it's not a question of Jupyter. It's really a question of what computation how do I want to use computation, and what kind of computational system provide me to run interesting examples for my class. And then once this question is solved, how do I integrate this into my class lectures, into my lecture notes? But Jupyter is only at this second part.
I guess I'm thinking of a situation where I have a bunch of math content in narrative form, and I could implement a library covering pretty much exactly the stuff
Mhm.
that I'm going to introduce theoretically in the lecture.
Yep.
And then it would be nice to like co-develop them in one notebook. I don't mind if
Would
what
you?
are the examples that you have, or what are the experiences that you have?
Most of the time, I'm trying to use as much features that are already there in the system. So I haven't had
Okay.
occasion where I had to redevelop. There were occasions where there were some additional utilities, but usually my goal is more to draw the attention to students. Hey, look at everything there and go play with this library. So I'm trying to teach them to use a library that could be interesting for them to learn.
We haven't really
Um,
considered that use case.
But yeah, otherwise, probably if it's a non-trivial amount of code, I would have some code files where I write the code and call it or show the code from the notebook along the way. Just because you quite often when you write this code, a big chunk of it is not directly relevant to the narration, or maybe inside the narration you want to show the code several times because you want to come back to it. So you just show whenever you actually want to show the code, just put question mark and you look at the code. All right. So here I've got a bunch of advanced topics. If I go into details in each of them, it's going to be slow. So what I'm going to just show the topics and you raise your hand if you want to.
But let me ask another question.
Sure.
So the Jupyter technology in some sense is extremely simple.
And to be as agnostic as possible.
But then Jupyter provides a huge amount of software support on top of that. And which parts of those have you found to be actually the critical ones that you use all the time?
Of the piece of Jupyter?
Yeah.
Actually, maybe this is going to answer you. What's coming or not? So ask again the question after, and maybe this helps. Yeah. So just raise your hand if you want more details for each of them. So yeah, I've shown you slides. Basically, it's just a usual notebook, and for each cell, you say whether it starts a new slide or whether it adds a new slide. So very basic model, but it works reasonably. And it's using Rise extension behind the scene. If you want to make small interactive applications, so Jupyter contains a widget system where you can, so here I'm defining a slider, defining a button, and saying that if I click on the button, then it should be the print of the value of the slider, and immediately you get, somebody is already keying my machine. Okay, no, this is. Should I try to disconnect from Zoom and try again? I mean, my machine is barely usable right now. What's going on?
Maybe turn off your camera.
Yeah, it's off. Yep. No, it's just Zoom is just.
Maybe restart.
Yeah, I tried to disconnect from Zoom. What do you?
Or maybe everybody can turn off the camera.
Yes.
I can, yeah.
Turn off the recording. Maybe that.
No, that shouldn't. Maybe that helps him.
Okay. Okay, seems to be better so far. All right. Then when you write a course, so your course ends up usually being a collection of notebooks, and it's handy if your student can just browse through the notebooks and have a view, and you can make it visible. So for an easy way to publish your course, you can use Jupyter Book, which make your collection of notebook into a static website. So essentially, we get yet another static website generator.
When you write that website?
Just it's a collection of notebooks.
Oh, but maybe you want to write some like segue text to introduce the notebook and to go to the next.
Yeah, well, it can be. It could be a.
Can I write like a meta notebook for that? Where I write one notebook that describes the structure of this book.
Well, it's a notebook, or you can just use a plain Markdown file. It's just very simple. Just notebooks, and you cross links.
It's just linking to the notebook. It's not doing anything else.
Oh, well, it uses things behind the scenes, so you can actually define cross references like you would do in LaTeX. So you could have named reference, and you will do the name resolution.
Oh, how does that work?
Backslash label, the equivalent of backslash label and backslash ref.
But I do cross references between notebooks. Huh?
Yeah. So in your notebook, you put a label someone, and then you can, when you put a link, you can put a name link, and it's going to make the link. Yeah. Nice. And then you get a book, and you can navigate around, and you can have features. I haven't activated them, but you can have features that when there is a cell, you can actually execute it online using FibiLab or this kind of features.
So what you just described as a label, that's one example of the notebook not being self-contained. Are there other features where the notebook are not self-contained?
Of course, external media, but you really think static web generator, you have a bunch of source files, which turns out to be notebooks in this case, or Markdown files to generate from there.
So I can link to something, but for example, I wouldn't be able to execute the function defined in a different notebook.
So what you can ask is when the notebook that is rendered here, you can either render without executing, or you can ask to execute all the cells there. And you can have some things where you can ask, oh, this value, store it, and then insert it somewhere inside any of the other document. That's small features like this, which we're actually using for current proposal from Candice. We're actually using Jupyter Book to produce it. And the budget file is created from the metadata by cranking. So which we get back to what we were doing with LaTeX proposal, but programming Python, and I feel more comfortable programming Python than in LaTeX.
Yeah.
And you can get basic search inside the book, and this is quite nice for students that don't remember, oh, where did we learn to play with files or to play with this, and you can do a search. Yeah, so if you want to deploy, if you want to make it easy for your students to access Jupyter, you can deploy Jupyter Hub. It can be somewhere depending on the kind of scale that you are reaching. We have one in Paris-Saclay, and it handles up to it's typically 100, 200 students simultaneously.
That's on a single server, or do you have a?
It's a big machine with 250 cores, which is a waste. In fact, but we want to switch. We want to something that can scale and unscale. We just haven't said it yet, and maybe we won't because Candice is going to take over depending on the time. One thing that is important is to have a reproducible environment, making sure that whatever you do on your machine is the same as on the server, as on students' laptops, if they install everything. And so one thing we do is we try each time to make a precise list of what we install in the environment. And typically we do it with conda packaging, something that works quite well. Reproducible teaching. So yeah, the difficulty with computer assignments compared to math assignment is if your math question is just slightly sloppy, you know that your student can go around. For a computer question, the exact same question can be trivial in some case and can become absolutely very hard just because the Python version got upgraded and you have this little additional difficulty that comes in. So it's very important to make sure that today my assignment is correct, even and to be able to check that whatever solution I had in mind actually work. So the recommended way is actually to not write the student version, but to write the instructor version. And then you can put just, again, it's very naive, but it does serve the purpose. You can just put those little annotation. This is a solution. And then you can use, for example, NB grader to strip out the solution and build the student version from there. And it's going to fail if you don't take action. And then it's quite nice to use continuous integration to actually do automated tests on all the solutions that you do. There is a question of managing assignments. How do I distribute? How do I get
sorry, do you also use it for automatic grading?
Yes, exactly. Yeah, so there is this question on how to distribute and collect assignments. I've come to the conclusion that when you teach a computational course, actually you are doing collaboration on code with your students. And so we should be using standard tools for code collaboration and for typically Forge. So there is this GitHub class model where when a student wants to work on an assignment is a Git repo, the student make a fork, play on the fork, push on GitHub, and then you can just look at the list of forks and you get to see all the assignments. So which is nice, but it's on GitHub, and I wanted to have it work on GitLab. And also I wanted this to work even for first-year students. We're telling them, oh, you should make a Git clone and commit. It's tough. So with colleagues, we automated this in a little library, and now we just have 2 commands: fetch, submit, and this automates the whole process. And that's been used by hundreds of first-year students, and this is working quite well. I mean, all the data is in GitLab. You can just access it through GitLab and then get all the nice features from GitLab, like continuous integration, etc., as a byproduct and build from there. So if
that's something we should have a look at, Dennis.
Yeah, I thought I might talk about this too.
Yeah.
This would be nice for the prologue assignments too.
Okay. So
Yeah, I think it would. Yes.
Happy to run the tutorial today. So yeah, it's just a small Python library, pip install, and then start from there.
Yeah.
And you have the whole range, having group managements and all the features. I like text files as a programmer. Notebooks are by default JSON, and I do advocate for using text files. So it's actually possible with this Jupyter extension to write notebooks in plain text or in Markdown. And so that's what I'm now systematically doing from all my classes. First, because this means that I can use my favorite text editor when I need to do this major query replace all over the place. It's comfortable. It plays better with versioning. It doesn't store output, which for this use case is a good thing, because if the student just execute his notebook, it changes states, which we don't care actually.
So this is a text-based language for Jupyter Notebook.
Yeah.
And it can convert back and forth between text.
Exactly. Jupyter can load it with the extension installed. You just load it as a normal notebook. So actually, this notebook is a text notebook. So I should show you it there. It's this guy here. So there is a little header with metadata, and this is typically where we could throw some additional interesting metadata.
Yeah.
of course, there is also, even in JSON format, you can input metadata, and then basically it's, I should make it a bit bigger. It's just Markdown, and you can have additional things. So here we see that this starts this marker plus to make a separation between cells, and then there can be metadata attached to this. So because this is a slideshow, but otherwise it's just a Markdown file. With
what is the code cell? What does that look like?
Code cell. This here is a code cell. So this is metadata. So
Oh, okay, yeah, because there you say.
that should be.
Free.
Yep. And the IPython3 here is just there for syntax highlighting. Whatever kernel is used is defined on top.
What else is the slide type?
So this is because this notebook is a slideshow. For each cell, I'm telling what role it is, and so this is the default role for a cell.
Right. Since you just mentioned that, is it still the case that you can only have one kernel per Jupyter node?
Yes. Yes.
That's a pity.
I agree.
Yeah. Like especially in teaching, if you can just look, here's the algorithm, here's what it looks like in Python, and here's what it looks like in C++ or something, that would be nice. That would be really useful. Yeah.
I'm still kind of thinking we should have a T kernel, but instead just have a Python function. Then run the MT parser and checker from within time.
Yeah, but it could be a generic kernel where you just specify each time. Oh, this is Python, this is C++, this is.
That's true, yeah.
And actually, the Python kernel, even just in the Python kernel, you can always push.
That's what I'm thinking. The Python kernel already has this feature, right? In the first line, you have an escape into a different language.
Yeah. So Bash, for example, most kernel, if you do.
Oh yeah, right.
Then you call Bash. So actually, you call a Bash kernel, but of course with limited capacities.
That's probably what I'll do.
You know, it's somehow it has been a design decision on Jupyter to keep the structure of a notebook really as stupid as possible. I mean, just thinking it just cells one after the other. When sometimes at the beginning, I would have wanted to have in the middle of the table have a computational cell.
Yeah, true. That's also
to put things more in the structure. And it has been a decision from them to keep it as stupid as possible so that it's easier to make sure that if anyone invents a new conversion from a notebook to someone else, the notebook format remains simple. And there is a point to that. So this is compensated in tools like Jupyter Book, where you can actually, when you convert to HTML, you can actually install the result of the cell should be put there, just to be nice. But it won't be interactive. And also important thing.
I have a short question. In normal or in non-text-based Jupyter notebooks, so in the, I don't know, classical format, whatever you want to call it, as far as I remember, there's a way to store the output or the results of your code in the notebook itself, in the sense of you run it once, you give it to somebody else and they don't have to rerun it to get all the data out.
Yep.
Is there something like that for the text notebooks as well?
That's a good question. Maybe some of the text format allows at least basic thing. For me, it's actually, for my use case of teaching, it's actually a feature that you don't get the output, notably to save space. Yeah, have a look at the Jupyter documentation. There is a variety of formats, and maybe some of them allow. I would be surprised if they would allow rich output, but at least having the text output would be meaningful. But I would need to.
All right.
So on the other end, one thing that can be done is you can ask Jupyter to save in both formats, so both in text format and notebook format. I mean, it tries to be a bit clever. So if you, with your text editor, you edit just the text format, the next time you launch in Jupyter, it's going to try to sync things together as much as it can, and it's going to retain the outputs in the Jupyter notebook. So you can have kind of both worlds simultaneously. It's working better than I would have worried. But yeah, most of the time I just don't care for the outputs in my case. And actually it's important in the data science class where you spend your time building a lot of outputs, a lot of images and things like this. Given that I want to store everything on GitLab, it would have exploded all GitLab resources by storing all results at every.
I can also see how you might want to use that for simple automated testing that you mentioned, I think, a couple slides ago, where you just want to check, does this thing still produce the same output with Python 3.10 or whatever the newest one is?
Yeah. Yeah, so which brings us to grading assignments. So you have tools like NB Grader. So first you can, since if you go this route of using GitLab for for assignment management, then you can just use continuous integration in whatever way you want. If it's about grading notebooks, you have this tool NB Grader that can help using the kind of thing that we have seen earlier. Essentially, you put assertion checks, and you say, oh, if this assertion fails, you lose that many points. Again, a very simple model, but since it's being simple means also it's quite flexible. You can do whatever magic you want in your own language, and it works quite well.
How do your students submit the homework?
So in my case, they push to GitLab. And so since they don't know how to do git commit, git push, and so on, they have a command, travel submit name of assignment, and it's being pushed to.
And how do you? So every student has their own repository, and you have a script to clone all of those repositories and grade them locally on your computer.
Exactly.
The grading happen on the server.
So the automatic grading is done by continuous integration. So whenever they push, it triggers continuous integration, which checks, runs all the automatic checks and put a score on the automatic part. And then myself, when I want to grade, I can collect, and it's really the script does a clone of all the forks. And then NB Grader has this form-based grading interface that allows to actually browse fairly quickly through the assignments with things like grading question by question, not sheet by sheet. So you can navigate quite quickly, assign grades, save, and push this back to GitLab. So it took a while to combine. So NB Grader was meant more for local use. So it took a while to actually make it work with GitLab. But now we have a complete workflow. And so nice thing is that students self-evaluate whenever they push. They know a couple of minutes later what their score is, which give them some incentive to try to do better until the deadline. Yeah, give early feedback and encourage them to go further.
But there is one big problem I see with this, which is if the students know all test cases, they could just point to the solution for those.
But first, in a couple of times, I did use some hashing so that actually I test what the result is without showing them what the result is supposed to be. Of course, you could brute force and try all of them. Would need to do some cryptography to push this further. The other thing is you can actually hide some tests. And NB Grader in the continuous integrate. Well, when NB Grader is going to grade, it's actually going to reinsert in the notebook some of the tests that have been hidden. And same way, if some cells if our cells are read-only, and if it's cheated by editing the file and changing the cells, NB Grader will first restore the cells to their original thing. So there are some protection against this. It's not 100% foolproof. But since you get a complete versioning of what they have done, if you are suspicious, you can actually check and say, you write something wrong.
How difficult was to set it up administratively that all the students have GitLab accounts?
So there's been a long-term thing, but actually, yeah, 5 years ago, actually, partly thanks to OpenRemKit inviting someone from someone else, we managed to convince the IT that we should have a university-wide GitLab, and then it's a university-wide GitLab, so all the students and everybody has access to the GitLab.
We have 2 of those actually, so it shouldn't be any problem here.
I was just wondering, like, let's say we actually want to use that for grading.
Mhm.
What hoops would we have to jump through to set it up?
If you have accounts, you don't need any. Yeah, as a teacher, I don't have any more rights than my students. It's just me. I create a group. I create my project. I assign just the usual permission management that you get in GitLab is enough. The only tricky part would be if you, right now, the assignment itself needs to be in a public repository. If I were in a situation where I wanted the assignment to be only visible to students, that would be a bit more complicated because then somehow GitLab would need to have a group, the group of students would need to be modeled. Here, GitLab doesn't have any connection with the learning management system. Just student can go there and they can claim to be student and submit.
I think most of you might run
We
into.
can compute on the list of students. From that we get the list of their personal university GitLab records.
It's single sign-on, so you have the ID.
And then we count them all. How do we set up continuous integration for all those repositories?
So essentially they make pull requests, and GitLab knows that.
Yeah,
And
so
then-
there is nothing specific to it. It's just they push, and there is a GitLab.yml file in the repository. So whenever they push, it's a repository with continuous integration, it triggers a continuous integration. The only thing is it does put some, so at the end of a lab session, when you have 100 students that submit at the same time, it does put a bit of pressure on GitLab server. On the previous one, we had to go through a few iterations to get the GitLab server to actually handle this smoothly. But
Yeah, our GitLab server is provided by the computing services. So it's good to give them a little bit of load.
How do you set up the continuous integration?
Via a .gitlab.yml file.
Do you need access to every student's
no,
GitLab,
so
or do they set it up themselves? Or-
no, it's just the assignment. So the assignment is a repository which contains a GitLab.yml. So when we do a fork of it, it still contains a GitLab.yml.
Oh, they all fork the assignment repo.
Yes.
Yeah.
And then they do a pull request to the.
Actually, they don't need. They just they fork and then they push to their fork, and everything happens on their fork.
And then there's some server that collects from all the forks.
And then myself, so I can ask Travo to collect for me all the forks of my assignments, and I get a local copy.
Who collects them?
Travo on my behalf, so my Python script.
Oh, okay. So you are the type to collect all the repos. Or do you have access to those repos?
Yes.
So the student need to give you access?
So that's why it's automated. So when when the students submit, so we have this command Travo submit the assignment, and it's going to do exactly all this magic: create the fork, commit, push the fork, configure, make the fork private, add all the instructors, give access to all the instructors, and so on. So it's using only features from GitLab, and in principle, it could be done with GitLab, pure GitLab, but it's just automated so that something that is a complicated sequence of operation just becomes a trivial operation.
The YML script for checking the test cases.
It's just running a script, so you do whatever magic you want for your. So Travo is completely independent of Jupyter. You could use it for anything else.
If you're hiding test cases, how does that work?
So this is a feature of NVGrader. So when you ask NVGrader to grade a notebook.
Wait, so what exactly is NVGrader? It evaluates the notebook.
Yeah, so
NVGrader as part of the YML script.
So NVGrader is, in general, it's a library for doing notebook grading, which involves a bunch of different steps. So in this case, we're only going to use the step of, I have a notebook, I want to grade it. And so NVGrader has a command, and the .yml script is going to call that command that takes a notebook, executes it, takes a notebook, check for the cells. If some cells that were supposed to be read-only have been modified or inserted in the original version. Ifs and the test cells are replaced with test cells with all the tests, not just the one that were shown originally. And then it executes a notebook and say, oh, there's still.
You run that on all the repos after collecting them.
It's even whenever you push, it triggers a continuous integration that
Does that.
does that. So there is one piece which I can tell you.
Where's the results get sent?
Locally, they are stored as an app. So when you do continuous integration and you produce some artifact, you can say, oh, this artifact should be stored on the
Okay, but then how do you get the storage?
I can ask so either I can go on the, actually maybe I would be clear if I go there. Question, should we still talk about this later and finish the talk and then have more?
Oh, sorry, I thought you were almost done.
No, I'm not quite half, I would think.
No, I'm almost done. I'm just worried about people outside that might get bored, or people that might come to me. So let's.
Okay.
I have to get going, unfortunately, at 6 sharp, because I have something personal I need to take care of.
Sure.
Very interesting talk. Looking forward to discussing some more of this during the week. Enjoy.
Cool.
It's going to be a recording. We'll make it available to people who want to see this.
Yeah, and there are just 5 slides left anyway. So there is a question of collaboration on assignments with students. So since we use GitLab, asynchronous collaboration is easy. I can do commits, I can do comments, I can do issues, whatever, pull requests on their assignments. In principle, Jupyter Lab provides now real-time collaboration. We haven't set it up on your server, but once it's set up, at any point, your student can send you a link, and then you can just connect to the notebook live and just play live the same notebook as they are.
Jonas, are you listening?
Intently.
Good.
Yeah.
By the way, if anyone tries to Google Travo, it helps to add Nicolas's name to the Google. Otherwise, you're gonna find 50 different travel apps for Android.
Okay. Yeah, I'll add GitLab.
Yeah, adding GitHub also didn't help, because then you find the source code to the 50 travel apps.
Interesting. One thing we haven't a good solution for is how to help students collaborate together on code. So if you're familiar with Git, we just say, okay, just use Git as usual. But we would like to be able to help students collaborate using Git and just making it a bit easier for beginners. And this is first work to be done. We have some ideas not to implement. But again, this is independent of Jupyter. This is written to Jupyter. So now just the last slides about this project. So where it came from is that in many universities, people have spent time deploying Jupyter Hub servers, and it still takes some time, as some people here not in this room can confirm. And not every university can afford to spend the time to do it. So that was the situation. And simultaneously, it has reached tiers pretty high, in particular at INRIA and so on. And so we started to think, oh, maybe the right thing to do would be to have a nationwide deployment so that all universities and even a small university could actually benefit from this kind of service. And this met this time where there's been all the investment, all the recovery packages. So there is about millions of money that are poured in different directions. And so in this framework, we submitted a proposal around 12 million euros to work on this for the next 3 years with possible extensions after. And this includes work on software itself to help Jupyter reach the scale, on deploying it, but also on how to use it to support and foster adoption and also co-construction in higher education, of course, but also in schools and high schools. And also this is sold as a research project. So there are sometimes ties from, so the argument is that by having a platform where many students do learn, well, we can use the data analysis, the learning analytics, and do interesting research there. So that will be part of this, not the part I'm the most familiar with. Of course, the question is, of course, yeah, it seems pretty clear that Jupyter can be useful for higher education, for high schools. My feeling was that, yeah, this would be reasonable. My first year student, it's useful for them, so maybe not for high schools, but I'm not a high school teacher. So the evidence that we have is that actually people have already deployed such a server, and in 2 years, it brought already 150,000 high school students to be using it. So there seems to be a strong need for this kind of and for improving those tools to actually make them easier to use in high school, or in even more if you start to go at lower education. But if we framed it in terms of Jupyter, but actually it's more like a short verb to try to convey what we mean. Really, it's about bringing open source scientific software at the fingertip of kids, students, and teachers. So it's not commonly specific to Jupyter. And really, it's about making it easy to have on-demand virtual environment that you can configure for computation. And I will restrict to lightweight computation. We're not aiming at GPU and all things which would rate a world kind of form. This making lightweight computation easily accessible to anyone. And the model is essentially it's a service, and you provide to the service a description of the virtual environment that you want to have, that is what software you want to have. And the model that's been chosen is it's provided as a list of Conda packages. So that's essentially the main specific decision where we are tying ourselves to a given technology. So the rest is fairly independent. And you may also provide a bunch of resources like notebooks and things like this. Of course, we would not expect any student or kid to type down the notebooks and so on. So actually, you can encapsulate all of this into a single URL, and then you distribute this URL to other teachers, to your students, and they just have to click this URL, and this will encode this description. And then what Candice will provide you is a virtual machine just for you with the software hosted on a trusted cloud provider, and the trusted cloud provider is a big thing. So that would be one of the difference with, say, Collab and all the many existing solutions. Some access to some physical resources, again, not GPUs, with software, with a persistent home directory. And within this virtual machine, you need to interact with it. So there should be a web server. The interaction will go from a web server. What does a web server? Whatever is installed. So typically it would be Jupyter, and this would be the main use case. But if you want to use RStudio, if you want to use Visual Studio or whatever, an empty web server, for no reason why it wouldn't work. So it's really providing, giving easy access to virtual machines with an easy way to configure them.
That's essentially Binder.
Yeah, except for the persistent home directory.
Indeed, yes.
So the main difference is authenticated persistent home directory and aiming high school, so scale.
Yeah.
But yes, definitely Binder is the model, one of the model. We think that there's a change to fly because we have the Binder experience that shows that.
Yeah, sure.
Secondary edition, you will recognize OpenDreamKit there.
Yeah.
So it's about deploying a given infrastructure for friends. But in fact, I'm interested in this infrastructure, but I find it even more important to actually support the software behind so that it becomes easy for others to deploy similar infrastructure, maybe for other countries, maybe to have eventually a European infrastructure that would do this. And also for people that would want to do similar things, not for education, but other purposes. So a lot of it's really an important mission to actually, the software development part is an important part of the mission. Anything? All right. And then just 3 topics. We've already touched on them, but 3 topics that I would like to discuss this week. if you want to discuss about Jupyter for teaching and go into more details at Twitter or whatever, I'm happy to discuss. I'd be interested in how you can add more semantic to teaching resources. So beforehand, it was about math. That was the last project. Now it's about teaching resources. How would it be possible to add semantic resources, semantic information to Jupyter? So to help teachers find resources, so that to foster reuse of resources, and to help students navigate into between them. So toward adaptive learning. And starting from something very concrete, I would like to start annotating the corpus of Jupyter notebooks that we already have.
Yeah.
We have to write down an intention letter for the collaboration between KWARC, FAU, and Candice, and already more is fighting. Thank you.
Very nice. So just to get, so Candice is probably decided on positively, but not officially. And
we hope so.
Who are the partners? I mean, do the 12 million all go to your lab, or
No.
what is the setup there?
So partners are, so it's what we call, so the client will be in area. So they will be taking the decision on where those are. Essentially, they will be play the role that our project officer was playing.
Yeah, okay. So they get the whole chunk of money and distribute it further.
Yeah, and do the review and check that what we do is meaningful and so on.
Which area is that?
Rocancourt.
Yeah, okay.
So it's Giraudon. Okay. So yeah, it's one person very near from the head of INRIA.
Okay. Yeah.
And actually, the head of INRIA is really pushing for this, which is also one thing where we're hoping it's going to fun. So INRIA will be the client checking, and it looks like it's going to be a more curious client than the project officer. We are going to actually dig in, and we will have a little bit less freedom.
I can imagine.
But it's also because we will have to deliver a product.
Yes. Yeah.
Which is instead of
How
research.
many partners are there besides Alice?
So in area for client, the coordination will be Paris-Saclay, and also leading the adoption in higher education.
That means you, or
that means me plus other people, but yeah.
But you're the head of the effort at.
Yeah, we'll play with a pair. So we hired a person that have less technical knowledge, but have strong political knowledge how to navigate large projects.
Excellent. So the managing director.
Yeah. And
you're the scientific director.
Yeah. In particular, because this project is going to be way more political.
Oh yeah, absolutely.
Than the previous one. This is about. Well, I'm learning.
Yeah.
For the software development part, it will be taken care of by a small company called Quantstack, which is led by Sylvain Corley, which you might have interacted with. Essentially, it's a small company. Most of the developers are core Jupyter developers. And essentially, there was a Jupyter community. Then they realized that there was a need for a company to be able to do software development to resolve many of the needs from the community, and so they started this company, and they just do open source software and Jupyter and so on.
Yeah,
I'm quite happy that they took on the task, because it's the right person to do this. Then there will be the running service, deploying running the service. And this will be done by FUN, France Université Numérique, which is a joint body from all universities in France that is specialized into deploying numerical infrastructure. So they started by doing MOOCs, so they have a big MOOC infrastructure. So it's FUN MOOC, maybe you have met, and then now they're going into also doing visual conferences. And because of our MOOC, they wanted to have a Jupyter deployment, and so that's how big. And so they are used to do large-scale deployment. So that's for the operation. The deployment itself is going to be on a private cloud provider, probably OVH or one of those that we trust, and also for negotiating out so that it's not Amazon. I'm not sure I trust Amazon for my student private data.
Yeah.
For the research part, it's going to be Université de Lorraine and in area there. So Anne Boyer will be leading this. There will be École Polytechnique. Will both be interested in the using higher education and use in high schools because they have strong connections with high school and doing a lot of actions, especially about how to teach math. And they've been involved in Jupyter for a long time. And the last bit is Académie de Paris, which is the institution that is above all high schools in the Paris region. And these are the persons that deployed Capital, the service. That they first deployed it for Paris and then deployed. So they have essentially they've managed this quite amazing thing to be able to do such a product where you need to have a large combination of know-how from teachers all the way down to running machines, and that all of this concentrated in their at their location. So that was a perfect location to start this. And also the difficulty we need to go go to the larger scale and then to start having. So it will be the tricky part where something that was born in a very centralized place will need to live and grow in a larger setting. So that's further interesting part here. Any other? So that's the core team. I think I forgot no one. And then there are a bunch of, and that will be the partners that will fund it. And then we invited anybody that would want to participate, like you, to have collaborations.
Okay, good.
So far on the principle that it's not funded, but we can provide the access to infrastructure, we can provide potentially some engineering work, time. And also Canvas is a small piece of a larger piece for numerical infrastructure for teaching. And a good chunk of the money there has been left open, and there will be calls. So
nice.
With the idea that we start collaboration, we do some experimentation. If there is something interesting that emerges, then we can apply to get 2 million euros to work on this specific topic. And that will be a process in the next 2, 3, 4 years. There will be a series of course.
Very nice.
And so we submitted the second iteration 3 weeks ago, and we hope to have a green light, an informal green light, in a couple of weeks.
The second iteration of
No, second.
Okay.
Is there time for audience questions, or should we wrap it up?
No, that's the KWARC tradition is it's over when the last one has asked the last question.
I only have 2. So I'm very interested in your Travo setup, because we too teach our first year students Git, but only in the 2nd semester.
Yep.
And it would be interesting to have a closer look at that. And I notice a lot of the time that the self-grading, or self-grading would be interesting, but I noticed that even without self-grading, a lot of students seemingly don't seem to run their code very often for testing. So code that I get still has a lot of errors in it, that just don't compile, for example. And do you have any experience with that? If this setups of self-grading a possibility instead of just one deadline where you submit the entire thing helps with that, or is neutral or is detrimental to that? What's your impression there?
That's a good question. So it might be quite different depending if it's more interactive computing in the notebook. So where we have a linear flow, and so we are following the flow, and so if you put a test there and test fails, it's right there on their eyes, and they can't quite ignore it. if we're more in usual programming mode where they use the compiler and so on, then it's a bit harder because you don't really, you have less control on the flow, you have less control in order they're going to do things and when they should be doing a specific thing. One thing that we try to do is among the notebooks to have a notebook which serves as a report. And so we ask them to write a few things there. But we also have some automated reporting. So in this notebook, we are going to run PyTest, for example, and we are going to run Flake 8 or whatever tools we want to have. So in principle, at the end, at least the student is supposed to run go through this notebook and run the test, run different things. And it's our hope that actually it encourages them to run the test. But the main thing is how much control do you have on their flow of action? If it's inside a notebook, you kind of have the control and you can make sure at this point in time, you need to take this action. Otherwise, it's harder.
I'd say for the course in particular, I'm thinking about it's like 80% notebooks. So
okay.
That could be, let's talk about that some more sometime this week. I could do Thursday, for example.
Okay.
That's free.
That's free. Perfect.
By the way, Jonas,
yeah,
colleagues from Rochester University, they've been experimenting with basically math students in this case, doing essentially undergraduate calculus, computing skills like thing. And they said they had enormously good results in giving them essentially automated, generated problems, and they could submit as often as they wanted. And they had the experience that the student would just keep going until they got everything right. And they were saying what you needed for this is relatively small problems and immediate feedback. And students would just
try.
butt their heads against the wall until they were through. And so this is something I think we should.
Immediate feedback is really something important.
And it's really motivating. They just don't give up.
I can imagine. I would love to have a look at the system in person. I can come in on Thursday. Is there time that's good for you?
I think Thursday is still open.
Okay,
so
I
would claim 11 o'clock.
Okay, so, then I'm claiming 1400.
Okay.
So for this, so I don't know what system that are using that Michel mentioned, but we're using a similar system for mathematics in France, which is called WIMS, which is old, but 20 years old, and it shows its age, but exactly this has been noticed. And also for our computer programming class, we are using another system which is called Platon, which is based also on the same system, same principle, small exercises. So we actually used it for serious grading during the confinement because we had nothing else. And the first time we put no limit on how many times they could try. And I was amazed how many times they actually tried, like 200 submissions on the same exercise.
Wow. Yeah, I also am very interested in this, what's it called? Synchronous collaboration. I haven't looked at that before. How do you use that in your courses? Is that TA to student or student to student?
So this is something that exists, but we haven't yet set up on our server.
Okay.
So yeah, I would be happy to actually take a bit of time with you because we need to investigate it at some point. And that's typically something where we could ask Sylvain Corley for help. Yeah. Because it's his company that made the final push on there. Yeah, and the use case I have in mind. So I don't have first-hand experience, but I've got a bunch of colleagues that do have experience with it because they're using the KWARC system where collaboration is built in from since a long time. And the typical use case is, so the two typical use case is either students that work jointly, so pair programming, or it's getting access to your student work. So doing the equivalent, so when you work remotely, doing the equivalent of what you do in the classroom to just sit next to him.
Right. So Andrea uses other systems that provide this, has used that extensively for software coaching. I don't think she would use a system that doesn't have it.
Yeah, I can immediately see how that would be helpful, because I always want to encourage my students to like, if anything isn't working and they don't know what isn't working or why. Currently, I often get screenshots of like Jupyter notebooks in the email, would be usually of the part of the code that works fine, not the part that is actually the problem. So something like this would be very helpful, I think. So let's also have a look at that on Thursday.
The intermediate step that we have right now is I often ask my students, okay, submit. Yeah. And then I can clone at least I can clone the repo and have access to the not the code itself. Yeah. And then I can play with and put even possibly, but that's asynchronous, and having synchronous access is better.
Yeah.
Especially in live discussion.
Yes. That's all my questions. Thank you. Very interesting. And I hope you get your project funded. It's very interesting.
Yeah, I do hope so. I've wasted so much time this year. Well, we'll see if it don't. For now, it's wasted.
You said you wanted never to coordinate a big project again, right? Now you're doing it even bigger, you want to do one.
I said I will not coordinate an EU project. I'm being a maître d'œuvre of a French project. I failed.
Yeah,
and it's definitely not a research project. The previous one already was not quite this one, which is actually worse because it's bringing me.
Granted, you less research.
Having a good managing director, one you can coordinate with, is an immense help.
She will
you have to be very sure that they don't want to do the research themselves.
Okay, well, this person doesn't have a research background.
Yeah, that's good.
So that will be perfect.
Yeah.
No, the thing we'll still need to. So first, she will need some training to get a better understanding, which is quick at grasping this. The piece where we need to synchronize is on the converge on which collaborative tools we should be using. And this is one part where I'm annoyed because since the beginning, INRIA is preventing me from using whatever tools I do think. Say, no, GitHub, that's too complicated. And this person is not from this, well, from the programming world as well. So I'm still in the process of showing her it's relevant.
Yeah.
And also to convince him, yes, I know it's a complicated tool, and I'm not going, and Candice won't be about proposing this tool for beginner teachers. I know the difference.
Yeah.
But I am speaking about coordination, and if you want to coordinate, you need good tools.
Absolutely.
It's some work.
Yeah.
And it's been a mess. And the proposal is not open. And this has been a frustration from the beginning.
Yes.
But anyway.
Good. More questions? Then we're done. So anybody else who wants to talk to Nicolas, I'm thinking that Frederick should also probably need show off our language stuff. And
shall we keep the recording?
yeah, no, we should stop recording.